Hello again for all participants in Data Science Summit Machine Learning Edition. With me is Jakub, Senior Data Science Consultant from Capgemini. So, hello, Jakub.
Hello.
And Jakub, you have very interesting topic from my perspective when I interested with process and security, etc. So online stand is yours.
Okay, perfect. Thank you very much. Hello, everyone. Welcome on the session, How Natural Language Processing Can Support Pharmaceutical R&D Process. My name is Jakub Ajchel, and I will tell you about one of recent projects that our data science team in Capgemini Invent Poland took part in. At the beginning, unfortunately, I have to apologize because my friend Ola was not able to join due to some health issues. She did fantastic work on the project and was responsible mainly for the technical part. So thanks to her, I'm able to tell you about our project. I hope that I will be able to answer all your questions at the end of the session. If not, please feel free to contact myself or Ola after the event. Okay, let's begin. The presentation today will be divided into three parts, starting with short introduction about motivation for this project, about our client and the starting situation and approach that we took. Then we'll move to some technical details. I'll speak shortly about large language models. And I will end today's session with presenting the results that we have achieved. On this slide, you can find contact details. As mentioned, please feel free to contact us after Data Science Summit. All right, our main motivation for this project was to design a tool that allows to ask domain questions using natural language, returning precise and up-to-date results in a user-friendly form. As you can see, there are multiple requirements that we had to fulfill, and I will show you how we managed to succeed. Our client is a global pharmaceutical and biotechnology company. It is headquartered in Western Europe and conducts its operations globally. As usually in big pharma, the company growth is through mainly acquisitions of competitors or small specialized companies or startups. Due to that reason, the company has now 3 independent research and development departments that are not fully connected to each other. So they have their own databases and they needed the generic tool to cooperate and improve the whole research process. One of the clear way for the improvement was to combine those data sources from each department. So there are more than 10 different sources they needed, including documents, articles, journals, patents, etc. But our client wanted to go a step further, and they look for obvious connections and dependencies between different sources. They wanted to achieve it to have the efficient development and investment. What is important is the fact that our client already had an internal search engine to look for dependencies across different sources. This was actually the initial phase of our project. So we built the tool called Predict that enables to find important relationship between authors, organizations, and terms. And those entities are presented in the form of graph, and you can see on the slide. Each node represents one entity. So, for example, a keyword or an author or an institution, while each edge represents the connection, the relationship between those entities. The thicker the edge is, the closest connection between them. User can click on the edge and find what are the reasons behind the connection, the relationship. In other words, what are the sources that combines both terms? Each graph is created by users that enters keywords they are interested in, and they can also specify the time frame because timeliness is very important. It is crucial in pharma, actually. And we wanted to give access for users to the most recent results. User was also able to specify the keywords that he or she wants to omit. And in that way, some unobvious relationships might be found, while obvious relations like between COVID-19 and vaccine, those two terms, those relationships might be neglected. Predict tool enables to quickly find new relationships between multiple sources. But our client wanted to go even one step further and create improved tool based on natural language for daily work. Together with our colleagues from across the Europe, we conducted extensive research on potential use cases, how we can implement NLP methods or newest findings in the generative AI. And we focus on the potential use cases and also concerns that our client might have. Specifically that this is the client from very specific pharma industry. Idea to use generative AI needed some validation. So we conducted multiple experiments that helped us to increase the accuracy, and we managed to build trust to large language models on our client side. Yeah, we proposed to develop an application, a functional proof of concept that allow researchers to use to interact with the tool and share the feedback to us that would increase the accuracy of our approach. So we managed to create a platform that transformed the data into the graph. This was the first step, and then we applied the generative AI. So maybe just to sum up our approach, because there are multiple steps. Those are the approach from the bottom, what we achieved. So first of all, of course, we combined 3 separate databases into one golden source. Then we enabled users to quickly search through the database by using keywords. And we managed to find relationships between those documents, and we built the graph. The next project phase started with combining existing tool with large language model. So we extended this one also by providing references to the documents and providing the credibility scores for each answer. We also enabled users to ask follow-up questions and to customize the whole platform. Yeah, so that's it regarding the general summary, the general approach we took. Let's focus now on capabilities and limitations of large language models that were used in our project. So very short and brief introduction on the models. I will not go into technical details because I'm aware that a lot of people on the audience already knows a lot about those models. Those are the hot topic nowadays. So I will not spend too much time on this. What's important to remember is that large language models are trained on vast amounts of text, and they are able to understand natural language and generate natural language. So they learn patterns and relationships between different words and phrases. The trained model can take input from the user. This input is usually referenced as prompt, and based on the training, it can generate text output. In that definition, I focused on text generation, but of course, there are multiple capabilities of large language models other than that, and we wanted to use those capabilities in our project. So LLMs can help in extracting valuable information and generate insights from large volumes of texts. This is very helpful in market research. This is helpful in customer feedback analysis. What's more, those models are useful in marketing and any profession that requires creating a written content, because they are able to autocomplete some texts. Large language models can generate abstracts, summarize the texts and whole documents, and this is the capability that is specifically important from the research and development area. Because it allows researchers to quickly determine if given article, if given paper is relevant to the research they are conducting. And without the need to read the whole paper, the whole document, they can decide if the given document is relevant. What's more, those models can imitate humans and take part in conversations by adjusting to feedback. And finally, they can support in sentiment analysis, identifying the emotions behind the text, what is important from the perspective of understanding the customer's opinions. For example, this is one of the use cases. Unfortunately, there are also some limitations of large language models, and we had to resolve all those limitations throughout our project. So one of the biggest risks of LLMs are hallucinations. So inventing incorrect answers when model lacks understanding. So especially in research and development in pharma, having correct answers is crucial, right? So this is the limitation that we had to resolve for sure. What is more usually the tools that are based on LLMs, lack of references. And also in research, we have to be able to provide some reference to the original document. So we resolve both problems at once. So our tool uses language skills that LLM has. However, we connected the model to the internal database, and this internal database was the preferred source of information. So thanks to this one, thanks to connection to the internal search engine that gathered all internal sources, and also thanks to usage of LangChain, the tool that I will explain a little bit later, we were able to provide references to all information provided as the output of the tool. We also provided the credibility score for each answer, so user would know how credible the result is. All internal documents that were used as the source for the tool come from the prestigious journals. So risk of having incorrect answer was very, very limited. Of course, there is a risk that a situation might occur when we don't have enough information in our internal database to provide the answer for the given question. In that case, the so-called vanilla response was prepared. So the response based on the publicly available information. However, user was always warned that this response might be incorrect, and it's better to double check the response. So what I covered here is reference as retrieval augmentation. So this is technique to retrieve relevant information from the internal knowledge base. In our case, it was internal research and development base. And this information is then provided to large language model. We can consider this internal base as some kind of window to that expose the model to the whole world beyond the data that the large language model is trained on. In that situation, we have two types of knowledge. We have the parametric knowledge. So this refers to the knowledge that large language model gained during the training. And this acts as a frozen snapshot of the reality in the moment that the data for the training was prepared. The second type of the knowledge is source knowledge, and this covers any information that is fed into a large language model via the input prompt. So we are able, and in that project, we were able to provide this valuable source knowledge using the predict tool, internal search engine tool, and the LangChain. Okay, to finish this slide and to discuss another issues that might appear So another one might be timing. So as an AI language model, some large language models does not have access to the real-time information unless we provide it to the model. We know that the cutoff date for some models from OpenAI is September 21. So it's almost 2 years of difference, and that is very difficult to cover in research. So by ensuring that internal sources are preferred sources of information in our application, and the most recent documents are available in the internal database, we are able to resolve that issue. Finally, one of the biggest concerns related to artificial intelligence in general is privacy and security. So we know that most models have to learn on the input, and usually users' input is also used to additionally retrain the models and in effect to improve them. As our client sources is private source and they are using not publicly available articles that are usually very expensive, they did not want to share those sources publicly, and they did not want to public model to learn on those sources. That is why the solution was stored on private space in Microsoft Azure, and Azure ensures that model uses private data, but this data is not used to train or retrain the model. Okay. We conducted the research within future users, and we prepared some ideas for the features that our application might cover. And it appeared that what is most important from the end user perspective is the trust and ability to adjust the final product to the user needs. Of course, model also had to be secure, had to be able to get the feedback and ensure the iterative conversations. So all those ideas, all those features we covered in our application, what I will explain soon. Okay, let's see how the technical stack looked like. Of course, large language model was the heart of our solution, and in our case, we used GPT-4 from OpenAI. On the next slide, I will explain you why exactly we use this model and the reasons behind them. What we also used was the LangChain. So the connector, it acts as connector between large language model and the internal search engine. LangChain is a framework, and it is designed to simplify the creation of applications with large language models. It is a very new tool. It was created, if I remember correctly, in end of 2022. But it is already integrated with multiple platforms as Microsoft Azure, what made it easy for us to implement it. I will not cover all features of LangChain, but I will only mention that it has multiple API wrappers for news, movie information, for weather. It also have multiple web scraping subsystems, and it supports connection to SQL or NoSQL database. So in our case, LangChain helped us to build this connection between large language model and internal search engine, and also to provide the references for the user. And as already mentioned, we used also Microsoft Azure as the cloud platform to ensure security and privacy. Whole backend was written in Python, including all data transformation, and the front end, we used JavaScript to prepare the front end to ensure the great user experience. Okay, let's have a quick look at the technical solution or technical overview of our application. So as mentioned, large language model was like heart of the whole application. And it was used to understand users' input, users' prompt in natural language. It extracted then the keywords from this text, and those keywords were passed to the internal search engine. In the same time, independent answer was created by the large language model in case we would not be able to find any document related to keywords in internal search engine. Okay, we found some documents based on keywords. Those documents are again sent to the large language model that was responsible for summarizing those documents and prepare the final answer to the user. The communication between LLM and search engine has multiple iterations. With each iteration, the response is cross-validated with the sources, but also refined. And at the last stage, the final response is generated by large language model and presented to the user. Throughout the project, we tested three different large language models. We started with BioGPT, so quite easy to host and open source model that was developed by Microsoft, and it is optimized for biomedical questions. It is because the fact that it was trained only on domain-specific data, so only on a big database with biomedical articles. And according to Microsoft research team, this model outperforms other models on like Google Bard, for example, on biomedical questions. It has quite good possibilities to generate the biomedical content. Unfortunately, it was very slow during our tests, and it was quite biased towards input data, so we decided to try something else. Our next try was GPT 3.5, so the model created by OpenAI, quite well known as ChatGPT, was fine-tuned from a series of those models. It was faster than BioGPT, and it surprisingly did quite well on the tasks related to biomedicine. However, in the complex scenarios, sometimes it was lacking the reasoning. This made us to try GPT-4, the next model from the OpenAI series, quite new, from March 2023, from this year. It was trained on publicly available data, but also on data from third-party providers. That's quite important to us. And it is described as more reliable and creative model. And it is also able to handle more nuanced questions from the users. It was also tested by Microsoft research team on medical problems, and it found out that even without any specific crafting of the prompts, it did very well on some medical exams in US, and also outperforms all other models, including those models that were specified in medicine. So we decided to go with this model. There are only two drawbacks. The first one is hallucinations, but I already explained that we were able to resolve it, and lack of explainability. But by adding references using LangChain, we were also able to give the explanations for each answer. All right, we already know motivation. We already know the technical approach. Let's have a quick look at the results that we have achieved. So with the project, we proved that large language models can fulfill very strict requirements in the research and development process in pharma industry. On that page, you can see the screenshot of the application itself. Unfortunately, I had to blur some parts of the text because it consists of information from private sources of our client. I hope that still you can understand the general context. So the screen looks very similar to ChatGPT. It makes it easy to interact with from the user's perspective. So we have here the main screen with the previous questions, answers, and after each sentence, you can see the reference to the document that this specific information comes from. By clicking on the reference, the new window appears, and the user can already see the text that was the basis for the answer. So it confirms the fact that I mentioned. If possible, always if possible, all information in answers are confirmed based on legit source. And here, each sentence have its own reference to the document from internal database. This is very important. Also, each result was presented with credibility score, so the number of tokens in the response with reference or citation divided by the total number of tokens in that response. There is also possibility to ask follow-up questions, and there is possibility to share or copy the response. So all those options are available. Okay, let's see what happens when we were not able to find any information in our internal database. So let's imagine the situation that we send the keywords. Yeah, we extracted the keywords from the question, we send it to predict, so to the internal search engine, and it was not able to find enough sources that might be included in the response. In that case, and only in that case, publicly available information from internet usually is presented in response. User always sees the warning that this is only so-called vanilla response, and there are no references in this response. So this warning, this lack of references, yeah, this is some kind of red flag to the user. Please double check what is here before you use the information given in your research. Our application offers also clickable modular answers with multiple options. We can see here that user asked about two big pharma companies, Sanofi and Bayer, and it returned the information about also other competitors in the pharma industry. So we have additional information here. And information about each competitor is stored in a separate box. So for each separate information, we have the own credibility score. We have possibility to ask different follow-up questions, etc. There is also possibility to show in network the answer. So show the whole graph from the internal search engine. And finally, let's see on the parameters that enable to customize the whole conversation. So user had a possibility to change the temperature parameter, so decide if the answer should be more creative, more precise. The result style also, it was adjustable, so user can decide if it should be rather in form of executive summary or explanation like to a 12-year-old child. Tone of voice were also adjustable, so if it's more neutral, confident, friendly, etc. So all those options were possible for the users, and user can also decide if he or she wants to see the statistics of cost and time used to generate each response. Yeah. After the implementation, we conducted qualitative and quantitative research to assess the impact of our tool. So it appeared that it brought very positive value. And first of all, the users experienced remarkable 4-fold reduction in search time for complex domain queries. So it means not only reduction of time needed for research process, but also reduction of costs. What is very important from the company perspective. Usage of the platform increased by 30% after we implement the connection with the large language model, so after the initial pilot phase with only search engine. And what is more, users that tested our application rated it either very good, so 7 to 8 points out of 10, or great, so 9 to 10 points out of 10. And all of the users expressed their willingness to use the new tool in the future research, in the future development of the new drugs, for example. So I think we made it quite clear that there is a positive impact of large language models in research and development, and yeah, that we can achieve a lot using those models. Thank you very much for today. That's all about our project. If you have any questions, please let me know. I also strongly encourage all of you to contact us, contact myself or Ola after Data Science Summit if you want to discuss more details of the project. Thank you very much.
Thank you very much for your presentation. I would like to remind, as always, please remember to evaluate the lecture. If you have any questions, ask them in comment below, because I know that Jakub has not many time with us. So please ask all your questions in comment below, and I'm pretty sure that this way will be the best that this for Jakub, for speaker to respond on them soon. So thank you very much, Jakub, for your presentation once again, and see you soon in the next Data Summit Machine Learning Edition.
Thank you very much.